Thank you everyone for joining us for our 5th webinar in the series, and this is Roll Construction Part 1 with Free Design and Classic with Copra RF 2011. For those of you who don't know me, my name is Carl Stevenson and I head up Datrem's UK operation for sales, support and service. I look after some of our UK and North American clients. I've been using Copra RF since 1994 and Copra FEA RF since 2009. I'm an open section design specialist, and previously I have worked at 2 of the UK's largest roll forming companies. More information can be found on me and my colleagues at the Datrem website. Let us move on to today's topic. First of all, we will be creating some axes in Copra RF 2011. First of all, we will be creating axes automatically, where we will define our initial machine layout and creating some top and bottom axes and creating our side roll axes. Following this, we'll look at then modifying these axes during roll design, increasing, decreasing top and bottom roll axes, diameters, modifying the side roll, and then creating some accessory axes. Following this, we'll move on to free design and discussing what is free design, and essentially designing from AutoCAD polylines, then modifying these polylines and free design rolls with AutoCAD and Copra commands. And then we'll look at adding to these roll contours, maybe some additional clearances for crimps, etc. And then we'll discuss what is classic roll design and creating entities for classic roll design, then modifying these entities with Copra's tools, in roll groups with Copra tools. And then, following this, we will discuss the 3D possibilities following roll design. Okay, so the first part of the procedure, once we've switched to our rolls module, is creating an axis. And our new version will take us to creating an axes automatically dialog box. And this is used in the very beginning of roll design only to modify and create axes diameters. So first of all, in here we'll create some top and bottom axes, specifying the roll drive diameter. This is the point of contact which will be coming into touch with the profile. Specify our vertical centers between the top and bottom axes, and we can then specify any climb and advance in these diameters throughout the roll train. We'll select some key stations where we would like to create some side roll axes, and we'll specify the overall shaft length, which of course is defined by our roll forming machine. Once we've done this, we will indicate the offset position. In other words, the location along this shaft length where the profile will sit. Once we've done this, during design, we'll look at finalising the top and bottom layout of stations. Obviously, because we may not always get it 100% correct during axes automatical. So in here we can modify our top and bottom axes, and we can specify our roll diameters, our vertical centers, and then indicate again drive diameter on the profile should it differ. We'll then look at finalising our left and right layout of the station, creating and modifying side roll axes by indicating a point on the profile and specifying a roll radii for this point on the profile. Once we've done this, we'll indicate our axis length. During roll design, it's also possible to create accessory axes. And this could be a rotated axis. And we'll create and modify an accessory axis with some simple construction in AutoCAD, specifying the axis location and length. And then we'll indicate this axis to Copra and specify a roll side. There are alternative ways of creating rotated axes by rotating side rolls also, but this is by far the most simplest. So, what is free design? Free design gives us the possibilities to design rolls into the Copra database directly from AutoCAD polylines. So if we've been a long-term user of AutoCAD to design our roll tools, it makes things very simple for us. We will then look at modifying these free-designed rolls. There are possibilities to do this as traditionally with AutoCAD and also by using some Copra tools. We will then look at adding to the roll contours we've designed by use of the Add Contour tool and a design polyline. We'll also discuss the possibility of converting to free design from Classic, and then we'll also discuss exporting possibilities. Following free design, we'll move on to Classic roll design. And what is Classic roll design? This is the sort of the long-term roll design possibilities within Copra. And this is designing rolls using Copra roll entities and creating these entities with Copra tools, be it with crosshairs or automatically. And then we'll look at modifying these entities with Copra tools and creating Copra entities from polylines. Again, a possibility for people who have been long-term AutoCAD roll tool designers. And then we'll also look at converting to Classic roll design, but bearing in mind it's not possible to have any undercuts in our rolls. But of course, Copra will remind us of this when we try any conversion. Once we have our rolls designed in Copra and they're stored in the database, there are possibilities then to view them in 3D mode. And this can be done via DTM, which is the traditional method of creating a DTM simulation of fading in our rolls. And more importantly, with Copra RF 2011, as we can see here on the left-hand view, by activating the 3D mode, and they will be displayed directly into AutoCAD. And then for those machine designers amongst us, there's a way to export into Inventor or SolidWorks. Naturally today, we may try exporting to Inventor. So, let's move to demonstrate of how this is done. Now you can see my Copra interface within AutoCAD. I will now create a new Copra project. This will be a Copra parametric project. And I'll just give it a simple name. And I'll just specify the material thickness. For those of you who are unfamiliar with this, I'm now giving the project a company name and specifying a profile number, in this case which is random, and a role set number, which of course can be different. We can see here the project path, and I'll be using our data.mcda, role attribute file, and a standard spreadsheet template. I'll now go to our section design tool, and in here I'm going to create a simple C section. Now 100mm wide, 15mm ellipse, 1.5 internal radii, and a height left and right of 50. And now I'll specify a plane of unfolding, and it will be the entity center here. And this plane of unfolding is of course correct. Now I'll create a very simple quick flower so we can begin some role design. So now I want to unfold. First of all, inserting the pass and create a simple bend sequence here. I have one saved, which will be adequate. Make a small modification in here. And create a simple bend sequence here. I'm now just going to create an archive of my flower. And for today's session, I won't actually do any optimization, as this was a subject of a previous webinar. I'm just going to now prepare my flower, ready to begin some role design. I will join these entities here. And here. And we can also now indicate that these entities should be joined here. And also here. This will be our entry guide station, so I'll specify some quick station attributes. And give a relative position of 280mm between passes. Once we've populated this, I can click OK. And now I'm ready to begin with some role design. So now I can suppress my spreadsheet and switch to the Roles tab over here in CAD Finder. So first of all, I'll go to Axes Automatical. And in here I have a machine called data M, which I'm going to modify. Now, of course, we can create one should we need to. In here, I have my machine identification, in this case data M, and we can see I have 13 stations available and also 13 profiles. The overall shaft length I will use is 300 millimeters. The roll drive diameter here is specified at 150. We can change this slightly to 145. I will fix this to the bottom here. My vertical centres I will leave at 160 for now. And you can see here I have some side roll axis possibilities from station 9 to 12. I'm going to change that from station 7 to 12 by highlighting them here. First of all, by holding down on station 7 and dragging down to 12. Ticking the radio button here to create some side roll axes, and then inputting the diameter, which I'll leave at 100 for now. As I mentioned previously, I have a shaft length of 300 millimeters, and this is defined by my roll forming machine, of course. I will also now add a small advance on the first few stations of 1 millimeter. And then you can see my vertical centres have changed again, so I'll now fix this again and type in here the 160. Click OK, and then you can see the distance to the machine side. My plane of unfolding will be 150 to 150, which will indicate the profile will be along the centre of my 300 millimeter shaft length. The reference for my diameters will be the point of unfolding, and now I can press OK and axes. Immediately you can see our top and bottom roll axes are drawn, and now we can browse through the flower using the browsing tools over here on the ribbon, and we can see we will need to increase the top and bottom axes here and potentially the side rolls also. So, let us return to station 1. So first of all, I will create a bottom roll using the free design functions. Now essentially, to do this, we need to create a polyline of our bottom roll. We have several ways to do this. We can of course draw one by using the polyline feature over here in AutoCAD, which will take the polyline from here to the apparent intersection of here and here to here. So I can draw a polyline in this manner. Alternatively, if I have the setting to do so, my Copra profile is also a polyline. So you can very easily use the break command from AutoCAD, break here, and then in the midpoint here. Because the profile is symmetrical, we can speed things up by just designing half of the profile. And now I'll modify the outside radius to an R0. And then we can see our profile here as a polyline. I'll increase the length over here in this direction to give me a lead into this first station. Now I'll take a quick dimension from here to here, which will tell me if I offset the bottom line, being the centre line, by 94, I should have a nice suitable flange diameter. Now if I take the fillet command, a radius of let's say 8 millimeters, I can first of all select the polyline here to here, and this will now give me my flange and base drive diameter. I now go to the free design panel of the rolls ribbon and hit the icon Create Roll. By clicking the polyline, I can specify whether the roll will be for the top or the bottom. In this case will be the bottom, and then I can hit OK and the roll will be drawn. And you can see here my roll weight in kilos is also specified. Now I have the possibility here to use the Modify Entities tool from the panel, which is a Copra tool, to add a chamfer. And I can do that here by going to the chamfer tool, picking the point here, and the width will be 2 millimeters by 45 degrees. We can see down here in the command line, and hitting enter. And Copra has drawn a chamfer for us. I'm just going to save the pass now to make sure that's in the Copra database before I continue. Now it may be a possibility where you may decide to actually split this roll here and manufacture this roll from two parts. And this can be done by using the free design command, split roll. So I'll pick the split roll command and go here. And you can see now our roll is split into two and is numbered separately. I escape the command and now go to roll groups. I can now mirror these design tools along the bottom axes at the end of the roll. And Copra will then draw them in for me. So you can see very quickly I now have 4 rolls along the bottom, but it's not always necessary to split these bottom 2 rolls. So again we can return to free design rolls, and this time we'll use the join rolls command, and we'll pick this first roll here and the second roll here. And there we can see the rolls are now joined together. So very quickly, using the polyline, we've been able to create a bottom roll, split the bottom roll into a flange, 2 separate flanges, and a base roll, a cylinder, mirror the roll to speed things up. So we're only designing for 1/2 of the profile in this example, and then join them. The next possibility is I'm going to use some classic roll design. Now you'll see this is the reason I join my entities in spreadsheet. I'm now going to create some classic entities for this station. So I go here to the panel, Entities for Current Pass, and I will then select the first entity I want to create, which will be here number 1, and the final one will be entity number 3. We now specify for which axes we would like these entities to be displayed for, and in this example it will be the top, and we just press OK. So now I'm going to modify this entity. I'm going to give some relief on entity 1 using a Copra tool. Now these again can be used in free design roles. So I'm going to modify this entity, pick the entity I want to modify, and it will be the angle. Now I need to indicate the modification angle. Well, first of all, I want to modify on the left hand side. So my adjacent entity here is grayed out, obviously because there are no adjacent entities yet on this side. And I'll modify this by 1 degree. We can see graphically here now in which direction this relief will be. If I was to put -2, you'll see we'll actually get a positive modification. It's important this box is ticked to keep the tangential transition of the radii here in the arc. If I press OK, you'll see the 1 degree modification is now applied. Just going to save this pass now to the database. And by using the explode tool, I can now use the bottom roll to give me some construction lines to create the top roll with Copa's classic entity tool, entities with crosshairs. So here you can see I've now exploded this polyline. Not to worry, when Copa redraws this, it will return to a polyline. So first of all, I'll do some offsetting here, just a material thickness offset, and a running clearance over here. And then what I will do is draw a line from here to here, and this will be my control of the strip edge. So now to create entities with crosshairs, we're asked for which axes. In this example will be the top. OK. And it will begin from over here, so I can use my object tracking tool in AutoCAD to specify the entity start point, just by hovering over the lines here. To the apparent intersection of here and here, and now using the object snap tool to the endpoints here to here. So now I can modify these entities using some Copa commands. So again, I return here to the Modify Entities toolbar. Again, I can take the chamfer tool over here, 2 millimeters by 45 degrees. And then I can add a radius, and we have to insert the radius tangentially here. So I pick the entity near the corner point and specify the radius to be inserted. Pi should be fine. And again, I can do the same here by picking the point, specifying a small radius, just a 0.25, and entering here. So again, you can see I have half of the top roll designed. What I will do now is return to the roll groups command, and I can again mirror the tool, and I want to mirror the top roll at the end of the roll. Press OK, and then you'll see our entities are created. Now the way to consider this, until these entities are collated, that each one of these individual entities is a specific roll. So we need to make them one solid roll. Here on the roll groups tool, we have create roll groups. So by picking this icon from the panel, I go here and I pick inside the entity on the left hand side, and then the last entity over here, and then the top roll is created. And of course, I now save pass. What I would generally do at this stage myself would create an archive file, a design stamp, a design freeze, and I would call this now rolls. We can see the top roll here is quite heavy. Now this could be over our desired material handling specification in our organisation, so we may decide to split this into 2 individual rolls, and this of course can be done using modify entities. So over here we have the possibility now to split entity. So once the command is active, the next point I pick would be the split point. So for example, the midpoint's here, and then of course we can now create the roll groups from here to here and here to here. So now you can see we have two considerably lighter rolls, much easier to manual handle. Again, I'll now save the pass. One thing to point out now, you can see here by the hashtag or the pound sign, on the bottom rolls are free design rolls, and the top rolls don't have this, so they will be classically designed rolls. Now, of course, it's possible to convert in either direction. So, for example, if I go to free design rolls now, I can convert a classic to a free design roll. So by going here, I can do one individual roll, or one pass, or the entire project. So let us just do one roll for an example. So then when I click the roll, it becomes a free design roll. You can see the hashtag here. And quite interestingly, with free design rolls, we have the possibility to add undercuts or roll contours, and this can be done by use of a polyline. So now I will draw a polyline over here, like so, nice and simple, and I can go to add contour here. And by clicking the polyline, that's now added. So the possibilities for this, remember, if I just save the pass, if I had some reason to add some clearance, maybe the addition of a crimp or a claw, I could just then, once I know the location of my crimp and claw, obviously by using the Copra tools as mentioned in a previous webinar, I would have a polyline like this. I could go to add contour. Bear with me 1 second. If I draw this onto layer 0, it will become visible in subsequent stations as well. I can then add this contour here, and then you'll see the roll contour now has this possibility. So that's a little bit about modification of rolls using free design and classic. I didn't quite finish everything here, so I'll just add a few radii. So I'll use a round roll corner. And the good news is, on this corner, I will need to add a radii manually. Now this is now going to use AutoCAD to modify a free design roll contour. So you may recall this is a polyline we split and created two individual flanges, mirrored and joined. So now I'll go here to the AutoCAD fillet command, specify the fillet, again an R1, and I'll fillet this line to this line. And you can see our polyline now. What I will do now is go to the Save Roll tool on the Free Design menu and save this roll contour. And then this will also be updated. So there we were able to use an AutoCAD tool to modify the roll contour. But of course it's always important to use the Save Roll function. And then I also use the Save Pass function. So that's free design and classic rolls. Let us now go to a station where we need to modify our axes. Interestingly here, we can now remove this clearance. For this example, we can see here that our top roll shaft will be actually quite close to the roll bore. So in this example, we would now go to axes top and bottom. You will see the dialog box is populated with the information from Axes Automatical. So what possibilities do we have here? Well, first of all, we can't really change for this machine the bottom roll diameter, so we have to fix that. we can increase the vertical centres. So the vertical centres can be increased by typing a value here, say to 170, which you can see the top roll is then updated to 192. I have a box ticked to specify the parameters on screen, and the reason being here, for this particular example, the usable shaft length will be 300 and the point of unfolding to the machine will be 100 and 150, which I don't want to change. I press the OK button here, and now I'm asked in the command line to pick the profile entity lying on the drive diameter. This will be entity 5. The starting point of the axis will be here, and the end point of the axis will be here. And you'll now see our axes have been increased to 170. Essentially, things still may look a little tight, so we can increase this further, maybe to 175. Untick this box, click OK, pick the profile line on the driving diameter, and you'll see that this is now increased and this looks more suitable. Our side rolls we may need to increase here. So first of all, I'll just do some quick construction of a bottom roll by taking a polyline from here to here. Modify the polyline here with some AutoCAD tools. And you can see I have a polyline. Go create roll over here for the bottom and have a bottom roll created. Save the pass, and now I can take a quick look here on how things could look for my side roll. Okay, so clearly I would have a 160 diameter roll here. Going to increase that slightly. So now I will go axes left and right. But I need some construction over here on the right hand side. So again, mirror roll groups, tool, the bottom, end, OK. And again, join these bottom rolls. And I have some construction now for my side roll axes. So, axes left and right. I'm going to create or modify these axes. So first of all, I go to get point in profile. And my diameter here, my maximum diameter of the side roll will be this location. And the radius reference for this now I want to make 100. And I can go the same on the opposite side. Again, get point in profile. On the right hand side here, specify the radius, in which case will be 100. Now the bottom point of the axis for me in this will be the shoulder I created on the bottom roll, which we can see is here. And in the length of my side roll axis, I want to make a nice round number of 60 millimeters. A description of each of these parameters is shown here graphically in the window. So of course you can manipulate these without actually returning to the AutoCAD window. Now press OK. And we can see our axes are updated. I can very quickly now, using the polyline function, create a side roll. Again, using AutoCAD tools. And now go to the create roll function, free design rolls. This time we specify for the left hand side. Okay, and then you can see our left hand side roll drawn in. And then over here, have the possibility in axes to mirror the side roll. And then save pass. So this is an example of modifying the top and bottom roll axes and also using the modify side roll axes and some nice handy tools for speeding up design time. Let us now go to the possibility of creating an accessory axis. So here you can see we now no longer have possibility to access the corner in station 10. So what I will do is create some simple construction of how I'll get an accessory roll into access entity number 7. I'll draw a polyline. To the center point. Offset by a nominal width. So now I can imagine my roll width here. And now by offsetting here the roll radius. Let's have some simple construction in AutoCAD for the location of my center line of my accessory axes. So if I go now to the axes menu and accessory rolls, I'm asked to identify the start point of the axes, which would be the bottom point here, and the end point of the axes, which will be the top point here, and now the side of the roll. We can see now that an accessory axis S1 has been created. Again, we have some possibilities to create some roll entities. Of course, we can use free design, as we've illustrated previously, or we can use classic. So I'm now going to create some entities for this current pass, and this would be from entity 6 to 8. This time we specify accessory axis S1. You can see now our axis is populated, and then we can modify these entities using Copra tools. Here and here. And we can round these roll corners here by 1 and here by 1. We can of course now create a roll group from here to here. Now we may decide that this diameter clearly doesn't seem to be big enough. So we now have the possibility to increase this. We can do this by offsetting the axes, say by 20 millimeters. And now I can return to axes, and we have the possibility now to move the axes. The axis we want to move is S1. Now, of course, we can move top, bottom, left or right in exactly the same manner. And we want to move S1 from this position here to here. Now you can see our roll is no longer big enough. What we can do, again, we can use free design, but we can also now take our roll from here to here. I'm going to place this on the layer which will not be drawn by Copra. And now I'm going to delete a roll. Okay, so if I do first of all Copra redraw, you can see the roll I don't want and the roll I do want. Go to roll groups and delete the roll here. So we have no roll on the S1 axis, but you can see our desired roll on layer 0. I can now go, imagine I constructed this roll as if I was going to use it for free design to create entities from a polyline. So over here, I can click on CAD icon, specify the axis I would like the roll to go to, select OK, and select the polyline. So in the same way we can create free design rolls, we can also create classically designed rolls from polylines. And of course we can now create roll groups from here to here. And I can save that station. Again, I just now create an archive, give it a number, some way of identifying it separately. So now you can see our rolls designed. We can remove this polyline now. So far. So now we can look at some 3D possibilities. With Copra RF 2011, we can highlight in our spreadsheet here, and then we return to the Copra menu here, and switch to 2D, 3D, and activate the 3D mode. Within a few seconds the rolls are drawn. And of course, if we go to the Copra Views menu, we can hit Realistic and see them. And then with the axes we specified earlier, over here, you can then look for roll collisions between stations, etc. So you have a quick handy tool to see if there will be any conflict in your roll tool designs. And we can return to the 2D mode. And then by clicking the light bulb, return to one individual flower. Now, as mentioned previously, you can use the browsing tools over here in CAD Finder to browse through your flower. Let's just return to the Rolls module. And if we wanted to now, we could export to 3D by writing, in my case, an Inventor interface, and then go into Inventor and selecting the file, and our model will be created automatically. So we've covered creating and modifying axes. We've covered creating free design rolls from polylines, and also classic rolls from polylines, and using AutoCAD and Copra to modify our roll tools. So that concludes our demonstration. At this point, I would ask if you had any questions, you can use the chat window via the NetViewer interface. If you type them in, I'll do my best to answer them. For further information upon our webinars in this series and for the remainder of 2011, you can find this on our Data-M website in your respective language session. Today's webinar will be recorded and you will receive a link via email where you can download today's session or any previous and future webinars. And of course, why not consider this medium for online training, saving you time and money, as you don't need to leave your office to be trained in the features of COPA you would like. And there are also some COPA RF workflow videos on our website where you can find further information upon desired workflow. And I'll thank you all for your attention. It's been a pleasure, and goodbye. And I look forward to seeing you in our next webinar.